All right, we're starting Unit 10, Day 1. This is going to be this whole unit. It's going to be about right triangle trigonometry, which should ring a bell from geometry. You did some of this. So this, like especially Day 1 here, is almost completely review from geometry. And if you remember, trig is just using these ratios. It's actually only half the ratios that we typically use, but this sine, cosine, and tangent, which in the calculator is sin, cos, and tan when you're using your calculator. But if you have a right triangle and you know the angle measurement, say this angle right here, the ratio of the bigger side, or sorry, the ratio of the opposite side to the hypotenuse will always be the same ratio. You know, for instance, one very, very common one is if I have a 30, 60, 90 triangle like this. If this is 30 degrees right here, this will always be a 1:2 ratio no matter what. You know, if I blow these up, this might be 2, but then that's going to be 4. And this becomes 10, that'll be 20. And it's always going to be a 1:2 or a 2:1 ratio, depending on how you want to say it. So luckily, our calculators have these ratios stored for every single angle. You know, if this was a 31-degree angle, well, this side would be a little bit longer. That still would be 2 there, but this, you know, this might be, instead of a 1:2 ratio, it'd be like a 1.05:2 ratio, and it would have the decimal form of that. So our calculators have all of these ratios memorized. You know, what their reduced ratios would be. Like I said, the reduced ratio is a 1:2. This could actually be 4:8. Well, 4/8 reduces to 1/2. So our calculators have all those ratios memorized. We just got to remember which one's which. And all these are names. Sine, cosine, and tangent are names for different ratios. Okay, so sine is when you're talking about the opposite side over the hypotenuse. Okay, so opposite over hypotenuse. And if I call this, let's see, A, B, let this be angle C down here, so this would be side B, side A, side C. It depends what angle you're talking about. So for instance here, sine of A, if I'm talking about this angle, the side opposite is the side that's not touching it in any way. These two sides actually make up angle A. You know, because of them, you know, those two sides are what makes the angle A what it is. Well, the side opposite that doesn't touch it in any way. That's what we're talking about here. So side opposite, so this would be A over, and then the hypotenuse is C. But if I said, what's the sine of B, if I'm talking about this angle, well, A and C make up angle B. You know, they create the angle, so the side opposite would be B, and the hypotenuse is C. So the hypotenuse is always the hypotenuse, no matter what. Hypotenuse is the hypotenuse, the longest side. Okay. Now cosine is if I want to talk about the adjacent and the hypotenuse, which is a little confusing to me sometimes because the hypotenuse is adjacent. So we say hypotenuse. Well, the fact that it's hypotenuse is more important than the fact that it's adjacent. So if I'm talking about angle A, both of these sides are adjacent to it because they make the angle, but this is the hypotenuse. So that means this is the adjacent side. Okay, so the adjacent side is the side that makes the angle, but not the hypotenuse. So this would be B over C. So B over C, the adjacent over hypotenuse. If I'm talking about angle A, well, these two sides make that, I'm sorry, angle B, I pointed at B and said A. Angle B, these two sides make the angle, but this is hypotenuse, so that's more important. So that's the hypotenuse, this is the adjacent then. So this would be A over C. So what the ratio is depends on what angle you're talking about. And then the tangent is the opposite over the adjacent. Okay, opposite over adjacent. So if I'm talking about angle A, opposite is A. The adjacent, remember, it's the side that's adjacent but not the hypotenuse. So B. So A over B. If I said tangent of B, well, here's angle B. Opposite is B. The side adjacent but not the hypotenuse. So when we say adjacent, we really mean adjacent but not the hypotenuse would be A. Okay? So that's just the ratio themselves. Okay, so if I go here, and you may remember how One way to remember it would be SOHCAHTOA. There's a lot of different ways. So sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. I've heard other people you don't say the S, C, and T, the sine, cosine, tangent. You say Oscar had a heap of apples. There's lots of other little sayings to help you remember whatever you want to use. Just find one that works. So SOHCAHTOA is what I always think about. So now we actually have some measurements here. So instead of just putting letters, I'm going to put numbers in. So T, look at angle T. The side opposite is 12. The hypotenuse is 20. And we want to reduce that as much as possible, so it'd be 3/5. So it'd be a 3 to 5 ratio. Okay, so this T is a 3 to 5 ratio, the opposite side, so the reduced is 3 to 5. So cosine of T, well, here's angle T. So adjacent over hypotenuse, well, the hypotenuse is 20. Now what side is adjacent but not the hypotenuse? 16. Okay, reduce that down 4/5. Tangent of T is opposite over adjacent, which when we say adjacent, we mean adjacent but not the hypotenuse, 16. That'd be 3/4. Now if I'm switching to a new angle, all the ratios change. They're going to be totally, well, not totally different, but it's going to be different orders, different. So sine of G, opposite over hypotenuse, 16 over 20, which is 4/5. Cosine of G, adjacent over hypotenuse, so 12/20, which would be a 3 to 5 ratio. And then tangent of G, opposite over adjacent, so 16 over 12, which is 4/3. Which if you notice, sine and cosine are always less than 1. And that's because you're always putting it's a ratio over hypotenuse. The hypotenuse is the biggest side. So the biggest over something smaller than that, or I'm sorry, under something smaller than that is always going to be less than 1. So these ratios always have to be less than 1. Tangent can be anything. You know, tangent, here's less than 1, here's greater than 1. It can go any way with that. Now, why does that ratio help us? Well, we can also use those ratios to set up equations and then solve. Okay, so we're going to set up some sine, cosine, tangent equations and use our calculator to solve it. Because remember, the calculator has what this ratio should be. Like here, I've got a 55-degree angle. I want this side opposite, and I know this side adjacent. Well, my calculator knows that if this is a 55-degree angle, what this ratio should be. I know exactly what it should be. So what I'm going to do is, if I'm looking at this angle, 55, the ratio I'm going to use is, I'm looking at opposite and adjacent, well, that's tangent. So that helps me decide which one to use, sine, cosine, or tangent. So tangent of 55 equals opposite over adjacent. And now I want to solve for x, and really this is a ratio and this is a ratio, so I've actually got a proportion here. So you say, you know, cross multiply and divide. Well, the problem is this is a decimal ratio. I would always recommend solve for x before you type in the calculator. So here, if I want to get x by itself, multiply both sides by 5 first. So 5 times tangent 55 would equal x, and you can actually type it in just like that in your calculator. Now, first thing you want to do, these are degrees. So make sure you push mode, make sure you're in degrees. See how mine says radian right now? I want it in degrees. You don't know what radians are yet, but you will by the end of this. Maybe you do know radians. I don't think they go over in geometry though, but so you want it in degrees. And now 5 tangent 55. You get 7.14. Now does that make sense that this would be 7.14? Well, that's 5, and now you don't want to go by looks because they're not always drawn to scale the pictures, but it makes sense that this would be about 7. Now, if I got an answer of like 42, well, if that's 5, that's not going to be 42. That's way too big of a difference, okay? But you know that in geometry, if this is 90 and this is 55, well, that means these two have to add up to 90, so this must be 35. That's only open 35 degrees, this is open 55 degrees. It's open a little bit wider, so its opposite side will be a little bit more than 5. So 7.14 makes sense, okay? So look at this guy. 40 is my angle. Adjacent side, hypotenuse side. Which ratio is that? That's cosine. So cosine of 40 is going to equal adjacent over hypotenuse. Now here, the x is in the denominator. Okay, so here x was in the numerator, just multiply the 5 over and I was done. Well, if x is in the denominator, you could solve for x doing a couple of steps, but one trick here, if x is ever in the denominator, just switch those two. So I'm going to say x equals 6 over cosine 40. So this will be, my calculator, I'm going to divide instead of multiply. So 6 divided by cosine 40, and I get 7.83. I forget what Math Excel wants you to round to. It might be the nearest tenth, but I'm going to do hundredths on the notes. So does that kind of make sense? Well, this is 40 degrees. That means this must be 60 degrees over here. I'm sorry, 50 degrees. So it would make sense. Well, if this is hypotenuse, it has to be more than that. I could try to find this side. I guess that's not really important, but this x needs to be more than 6, but not a whole lot more. It's not going to be like 50. But 7.83 is a reasonable answer. So here I've got 37 is my angle, so I'm looking at from 37's perspective, opposite side and adjacent. So tangent 37 equals opposite over adjacent. Okay, variables on top, I can just multiply the 3 over. So 3 tangent 37. Okay. And that it seems reasonable. This is 3, 2.26. This is 37 degrees. That means that's going to be more than 37 because they have to add up to 90. So that's less than halfway. That's going to be more. And so on. So let's go a little bit faster. Oh, one on the back here is, what if the angle is missing? Okay. So all those in the front, we're missing sides. So from this angle's perspective, so angle x, I've got the adjacent and the hypotenuse. So that's cosine, adjacent over hypotenuse, adjacent over hypotenuse. Now for the calculator, if you want to solve for x, to get rid of cosine, I want to do the inverse operation of cosine. Remember, like if you're adding, the inverse is subtracting. If you're multiplying, the inverse is division. Well, on the calculator, the inverse of cosine would be inverse cosine. If you look on your calculator here, we push these cosine buttons. Right above it is cosine to the -1. Well, that -1 doesn't mean an exponent, it means the inverse of. So I'm going to do the inverse of cosine, the inverse of tangent. So I would do to both sides here, I would take the inverse cosine of this, and I'm going to take so that's hard to write, I'll write this. So inverse cosine of 8 over 18. So I'm going to do the inverse cosine of both sides. Well, if you do the inverse cosine of cosine, they wipe each other out and you're left with x. So this x would equal, and in the calculator I'm going to type this in. So second cosine of the -1, and in parentheses 8 divided by 18. So I'm going to tell it the ratio. So your calculator basically says, what's the ratio? We'll tell you the angle. So if you know the ratio, 8 over 18, you put the reduced ratio in or you put the exact ratio in. It doesn't matter. So 8 over 18, or I could put 4 over 9. That seems like extra work to me, so I'm just going to put 8 over 18, hit enter. The angle is a 63.6 degree angle. Okay, so if you feel really confident with this, you just try the rest of them and fast forward to the video, because that's basically what I'm going to be doing here. I'm going to go a little bit faster though. So this one, opposite over hypotenuse. So sine 28 equals x over 15. Multiply the 15 over. This equals x. So x equals 7.04. So here, x opposite hypotenuse. So that's sine. So the sine of x equals 6 over 9, opposite of hypotenuse. This is one of those we're going to have to do the inverse sine. Inverse sine of 6 over 9. Well, on this side, the inverse sine of sine is just x. And the inverse sine of 6 over 9 would be 41.8 degrees. Opposite of hypotenuse. So sine x equals 4 over 5. Again, inverse sine of 4 over 5 is what we need. Put in the calculator, 53.13. X equals, I should put x equals there. This one here, opposite over adjacent, so that's tangent. So the ratio is 8 over 10. So I need to do the inverse tangent of 8 over 10. So x is going to equal the inverse tangent of 8 over 10, which is 38.7 degrees. And then the last one, opposite over hypotenuse. So that's sine. Now the angle is 70. I know the sine. I know the angle. So opposite over hypotenuse. Multiply the 7 over. And then put it in the calculator, and this was 6.58. Let me try that. Let's see, 7 sine 70. So 5.8, yeah, 6.58. Yeah, so hopefully that's a review. You did a lot of that in geometry. You did like a whole unit on using right trig. So now solve all the missing parts. So I'm missing a y, x, and a z. Well, the y is going to be easiest because these three angles have to add up to 180. Well, here's 90. That's already taken care of. So these two have to add up to 90. So I'm going to do 90 minus 39. And I get 51. So y is 51 degrees. If I want to find x and z, I got options. You could do, for 39, you could do opposite over hypotenuse, that'd be sine. You could also use cosine of 51. So cosine of 51 would be 11 over x. So it's really up to you which one you want to do. I'll just do sine 39, opposite over hypotenuse. So opposite over hypotenuse. And this is one where, since the variable's on bottom, just switch them. So 11 divided by sine 39 is 17.48. Does that make sense? Well, if a leg is 11, the hypotenuse has to be a little bit bigger. So it kind of makes sense that it'll be a little bit bigger. And then for the last side, you could do Pythagorean theorem if you want, or I'm just going to use my right triangle trig. So I'm going to say 39 opposite adjacent. So that'd be tangent of 39 equals opposite over adjacent. Again, flip-flop those. So z would equal 11 over tangent 39. And so if I put that in the calculator, so 11 divided by tangent 39, you get 13.58. So x, y, z. Whoops, let me put it in the picture there, x, y, z. This is not the only way to find them, by the way. This is just the way I chose, because you could do a couple different combinations using different ratios with different sides, and you would also get the correct answer.